Hi, I'm Deepa. So this is the image level data I've been working on for the client. So this is the details of the data of one node. So there is too much detail of one data, and client wanted search queries for this data. Like this dates do not control the data when the pictures was clicked, because this is the data when di- the index is created and data is loaded into the Kibana. So we can see here, like if we want to see photos over time, we can simply do it like 2021, like okay, greater than. So we can choose here 2015 New Year and, 2020 New Year. Yeah, so now we can see the number of hits have been changed because of the data is filtered. Like if we see the index is created on 21st 2021 April 17, but the data date and the datetime original was 2018. And similarly, like clear this query and we like take a label name, not label name, but yeah, camera. Uh, we can see like what camera is used here. So we can see here the exit data lens make model is well, like for Apple, and this is also like description is also Apple lens model after Apple. So let's go to the top and select our images by camera. So here we can see this is the lens model. So we can do it for Apple here. Apple here. It will take some time. Okay, so we can't see any data for Apple, so we will have to replace it with like real model name. That is the company. This is the brand. And if we see now, it is searching for the data. And now we can see for 14,000 data is present in our like timeline. And similarly, we can use uh, camera over time. Here the time filter will also come into the place. Like we can select the camera model here and then date here. So it will work on two queries at once. And again, if we see the data by label, so here we have selected person and human, and other one is parent name is person, parent name label is person. So the data will change accordingly and give us the I don't know. Yeah, so the 17,519 hits are there for the where the label is either person or human and the parent label is person again. So yes, these are the queries and we can select the label over time also by this query. Yeah. And these are the visualization I made for the client. Like this shows the uh, distribution of companies that make the camera over the time yearly distribution. Like 2016 we can see Canon made 1049 and Samsung made for like in the data we have for Canon 1049 in 2016, and for Apple we have 3860 in 2016. So if we want to look at the data, like we can see the most of the data is not present. Like we want to compare, we can see there are two similar type of data here. So we want to compare these two. So we can just select the time range like this. And now we can see the distribution of these three Samsung, Apple and Canon in 2015, 16 and 17 respectively. You can see here that this is the 12-month period. Okay, so this is on the same timeline, but here our company is divided into models. So we can search for any model that we want to see, like Samsung SMG 900A. Like we have 4,509 entries for it, the most entries. And again, we can look at the distribution here. Yeah, so this will help us in doing that thing. So here the no result found because we have selected the time filter here. So we just go back, so the filter get removed, and now we can see the data is loaded again. We can see the model count, like Apple made iPhone 6s and 6s model, um, and we have 6,927 entries for this model by this company. So this is the distribution of models within the company, and the frequency distribution is given by the count column here. And the label name count is also showing the number of labels we have. Like a picture may have multiple labels for it, like a human person will also fall in the same category. So we are just counting the number of person labels in all the data sets and clothing. This is not excluding anything, and we can see there are too many, like thousands of entries here, like thousands of labels for which we have the count here. Yeah, so that's all I did for the client here.